Hello folks, so let's get going with the whole AWS Aurora Immersion Day and let's finish this up. We still have 3.5 hours and Amazon Aurora Global Database is what we're going to be looking at first, and then we have machine learning part, the SageMaker, and we also have database activity streams and IAM authentication to access the database cluster. Cool. So let's get going. I think I'll just click these here, keep it ready for later. Maybe I'll keep it over here. Database activity streams. Okay. Cool. So let's sign in again. Okay, just a moment. I just need to do this. Yep. Cool. Okay, so yeah. We'll go through a series of Aurora MySQL global database labs in this section. So this section contains the following labs: deploy an Aurora global database, connect an application to Aurora global database, monitor a global database, use writer forwarding, write forwarding, and then Aurora global database switch over, Aurora global database failover. Cool. So let's get started. So deploy an Aurora global database. Amazon Aurora global database is designed for globally distributed applications, allowing a single Amazon Aurora database to span multiple AWS regions. So in our current case, I think the cluster sits in US West 2, which is Oregon. So it's deployed there, it's running there. So if it's global, it means it is spanning multiple AWS regions. So this is running in US West 2, 2D availability zone, and then 2B availability zone. So it replicates your data with no impact on database performance, enables fast local reads with low latency in each region. So employs disaster recovery from region-wide outages. This lab contains the following tasks: create an Aurora global cluster. So due to multi-region nature of a global database, you'll often be switching between two regions to accomplish the tasks in this lab. Please be mindful that you are performing the actions in the proper region, as some of the resources created are very similar between the two regions. You will refer to the region where your current DB cluster is deployed and you have been working in so far as your primary region. Okay. Currently our DB cluster is deployed, and what we've been working so far is primary region, which is US West 2. So you can actually see it here. It's US West 2. So this is the one. Just a moment. Yeah. So we'll refer to the region where you will deploy the secondary read-only database cluster as the secondary region. To simplify the getting started experience with the labs, we have created the prerequisites resources like VPC, security groups, etc. in the secondary region. If you're running a facilitator-led lab, then the secondary region is chosen for you as North Virginia, which is US East 1. If you're running these labs in your account by deploying the stack yourself, then you would have chosen a secondary region during the initial launch. Navigate to CloudFormation console and US East 1. Make sure you've chosen the correct secondary region. Okay, so we are going to go to the CloudFormation console. So you can actually see that this is opening up US East 1. This is also US East 1 only, but anyways, let me open it up. So you can actually see this is the US East 1. And click the stacks on the left navigation panel. Under the stacks column, click the stack that starts with the name stack set Aurora lab, right? So it just says stack set Aurora lab. So this is the one. Okay, so click stacks on the, okay, so once the status of the stack is create complete, click the outputs tab. The values here will be critical to the completion of the remainder of the lab. Please take a moment to save these values somewhere that you will have easy access to them during the remainder of the lab. The names that appear in the key column are referenced directly in the instructions and subsequent steps using the parameter format output key. Okay, so let's open this up. Outputs. Okay, so let's close this. Oh, interesting. This is the value here. So it's these and these. Okay. So let me just get these values down. We need the client side, client ID, URL, and stuff. And we need this. Okay. S3 bucket and all that. Superset password and all. Okay. So let's put this here. Okay, so cool. This is in US East 1. We'll also call it as secondary region, and for global database, global stuff, right? So now that we have this, let's click next. So create an Aurora global cluster. Okay, so the lab environment that was provisioned automatically for you already has an Aurora MySQL DB cluster. You will create a global database cluster using this existing DB cluster as the primary. Okay, so basically this is about global cluster versus DB cluster. What is the difference? Okay, so a DB cluster exists in one region only. It is a container for up to 16 database instances that share the same storage volume. This is, I don't know why it says same storage volume. It's not the same storage volume. Anyways, this it's like related but not the same. I don't know. This is the traditional configuration of an Aurora cluster. Whether you are deploying a provisioned serverless or multi-master cluster, you are deploying a database cluster within a single region. A global cluster or global database cluster is a container for several database clusters, each located in a different region that act as a cohesive database. A global cluster is comprised of a primary DB cluster in one given region that is able to accept writes, and up to 5 secondary database clusters that are read-only, each in a different region. Each one of the database clusters in a given global cluster have their own storage volume. However, data is replicated from the primary cluster to each of the secondary clusters asynchronously using a purpose-built, low-latency and high-throughput replication system. So ensure you are still working in the primary region, especially if you are following the links above to open the service console. So Aurora MySQL cluster and add AWS region. Okay. So here we are, Aurora. This is US West 2. Yeah. So this is our primary region, Aurora MySQL cluster. So click this and add AWS region, right? Okay. So global database settings section, set global database identifier as Aurora MySQL global. Okay. So I need to these I got it. So I'm just gonna close these up. This one global region is US East Virginia, North Virginia. Okay. So secondary region is that. Instance configuration R6G large. I think these are. Is it Aurora IO optimized or what? I think they don't mention about all that. Anyways, I could choose memory optimized classes DB R6.large. Okay. db.r6g.large. Okay, and then availability and durability, don't create a Aurora replica. Okay, create an Aurora replica or reader node in a different availability zone, recommended for scaled availability. Okay, anyways, I'm not going to create, so scroll down in the connectivity section, specify where the database cluster will be deployed within your defined network configuration created above. Aurora Lab VPC, so we have our Aurora Lab VPC, yup. And then enter the correct subnet group, ensure the correct subnet group was selected automatically. It should be named Aurora Lab DB subnet group. Make sure the publicly accessible option is set to no, yup. Of course, no. We don't want it any public IP address and all. Only EC2 instances and other resources inside the VPC can connect to the cluster. So no, this should be no. It should not be yes. Choose one or more VPC security groups that specify which resources can connect to this cluster. So choose existing for VPC security group. Choose existing and pick the security group named Aurora Lab Database SG. Remove any other security groups such as default from the selection. For encryption key, use AWS key management system key drop down and select default AWS RDS selection. Okay, remove this. Database availability zone, nothing additional. This one is set. And then global write forwarding, we are not going to choose it again. Oh, we are going to be choosing it. Okay, check global write forwarding. Okay, issue cross region write operations from secondary DB clusters. Why is there no advanced thing available? I don't know. Expand the additional configuration section and configure the following options. Instance identifier, node 3, secondary. Okay, global options, instance identifier, and then this one is a MySQL secondary. So okay, is so Aurora Lab MySQL global instance one. Anyways, we'll actually put this as Aurora MySQL global cluster one. Okay, we'll put this as this. Okay. Oh wow. Okay. Aurora MySQL secondary. Wait 1 minute. Cluster identifier is that. Instance identifier is this. Okay, and then parameter group. Stack set. Aurora Lab. Okay, there are 2 of them. This is for 0 ETL, so I'll just choose this. Backup retention period 1 day. Turn on performance insights. Okay, where is performance insights? I think performance insights comes here. Okay, retention days 7 days default. AWS RDS, enhanced monitoring. Yup, sir. Granularity 1 second. Aurora Lab monitor secondary region. US Eastern. Okay, this one I have not changed it before. This is the first time I'm changing, but anyways. And one second. Okay, And then uncheck enable auto minor version upgrade. Yeah, enabling auto minor version will automatically upgrade your database minor version. For limitations and more details, see automatically upgrade. So let's uncheck that. Okay, done. That's done. And what do these selections mean? So you will create a global cluster, secondary database cluster, and a database instance in that secondary cluster with associated configurations in one step. Your existing database cluster will become the primary database cluster in the new global cluster. These are distinct API calls to the RDS service. These are distinct API calls to the RDS service. Should you create a global cluster using the AWS CLI SDKs or other tools, the RDS service console simply combines these distinct steps into a single operation. Okay. So different API calls apparently. Okay. So click add region to provision the global cluster. Okay. I chose the DB parameter group, cluster parameter. Okay. This one parameter group is the same. Okay. Cool. So the global cluster, including the secondary database cluster and the instance, may take up to 30 minutes to provision. Wow. Okay. So creating a global cluster based on the existing DB cluster is a seamless operation. Your workload will not experience any disruption. You can monitor the performance metrics of the load generators started above throughout this operation to validate. Okay. So when you create this, I think you should be able to see sign in. So MySQL cluster secondary, yeah. So you can see it here, and I think it'll show up here also. Yeah. Global MySQL cluster. This is the secondary. It's over here itself. This one is a different region. United States Oregon. You can see this over here. Both will show the global, I think. Here it's Oregon and here it's North Virginia, US East 1, and here it's US West 2. You can see the global cluster related stuff over here, configuration and all. No recommendations. Oh, there is recommendations. There are recommendations. Anyways, so you can see how it shows MySQL cluster 1. It has to go to US West 2, US West 2. Right, and here this is actually here itself. Interesting stuff. So the endpoints section in the connectivity and security tab of the details page displays the endpoints. Note these values down as you will use them later. Okay, cool. So let me you can't just look at these here. Yeah, if you click them, it will go there only, and you can't look at these here. So we need the secondary, the cluster endpoint. Okay, not the connectivity and this. We need this. It's inactive as of now. This is creating. Writer will not come up. Only reader, I guess we need. We need the reader. So read only here, because this is a replica. So as of now we can't use this. So we'll copy this, and this one does not have any endpoint as of now, so it's fine. Anyways, I'll keep this handy. Yeah, cool. So now let's move on. So we have a global database cluster. Awesome. Connect an application to Aurora Global Database. Amazon Aurora provides both MySQL and PostgreSQL compatible database engines. This means any existing applications that work with MySQL and PostgreSQL will have drop-in compatibility with Amazon Aurora. In this lab, you will configure a business intelligence application operating in each of the two regions and connect it to the respective local database cluster reader endpoint of the Aurora Global Database in order to achieve lower query latency. For the purpose of this workshop, you will be using Apache Superset. Okay. So yeah, this is actually business intelligence thing. So as the application, Superset is an open source business intelligence and data exploration platform designed to be visual, intuitive, and interactive. So this lab contains the following tasks: gather the needed information, configure application in primary region, configure application in secondary region, access data using the application. Okay. Cool. So Apache Superset has already been installed in your lab environment, but you'll need to retrieve the URL of the Superset web application and the username and password. So you'll need to retrieve these details for both the primary and secondary regions. Similarly, you need to retrieve the database cluster endpoints for both the primary and secondary database clusters as well as the database access credentials. This table provides an overview of where you can find this information with detailed steps below. So DB credentials is in secrets manager secret. The cloud formation stack outputs have everything else. This was the URL, username and password, Aurora cluster endpoint, reader endpoint. So location and second not available in secondary region. So with this we have to go and same as in primary region. This one we have to get it after it's created. So not available in secondary region. RDS service console. So here you can actually see that there's a reader. Okay. Yeah. So reader endpoint basically is an RDS service console. Yeah, cloud formation stack. Okay. Cool. In the primary region, open the thing console. Okay. Click on the stack named Aurora, either Aurora or something like that. Yeah. Outputs, and you should find the superset stuff here. Right. So ensure you're still working in the primary region, especially if you're following the links above to open the service console at the right screen. So this is US East West 2, so the primary region. So I remember getting these values before also, but anyway I'll get it again. I think it was here, Aurora test something. Yeah, this was the one. Right. So now superset URL username password, cluster endpoint and reader endpoint. We need the cluster endpoint and reader endpoint. So reader endpoint is this. Where's the cluster endpoint? It's this. Cool. So it's cool how you can just select this and get properly. So and find the values when I can make a note of them. Okay, got it, done. Yeah, if these values are not present, you may not have selected the correct region or the lab environment was not initialized with the global database feature enabled. If you're participating in an organized event, please reach out to a lab assistant for help. So how can you check the inputs of this lab? Parameters. Yeah, agree tracking, yes. Deploy IO optimize, deploy GDB, global database, global deploy cluster, backtrack. Is secondary? No, it's the primary. Is workshop studio environment? Yes. Cool. So they have put all these parameters true. So I think you're good to go. Yes, ML, yes, 0 ETL, everything. Yeah. Cool. So this is the template if we need it. I think this will create the whole thing. We can actually just copy this and keep it and store it here. Cloud formation template .yaml. So that's the one. So this will deploy the whole thing. It's pretty cool, right? What happened here? So this is not exactly YAML, I guess, but similar to YAML. Anyways, so cool. So let's close this for now. And update stack, security chain set, stack actions. Anyways, chain sets, git sync. Okay, so I don't have access to git sync blocker summary, okay, code connections. I don't have access here, so cool. So resources. So this shows the different resources that got created. Subnet, route table, SRT, route table association, subnet route table SRT association, and then to public full. Okay. So events, a lot of events here. View root cause and all, something is there. So can you choose the event? No, I don't know. Then why does it say root cause? I don't know. Anyway, so with this, let's look at this. Next, also in the primary region, open the secrets manager service console. Click on the secret, starting with secret, and scroll down. Retrieve secret value. Okay. So I think here we're done. This one we have the secret, but I'll get it again. So we still have 3 hours. Quickly, let's get it done. So this one, retrieve secret value, and let's get this in plain text. Yeah. So there we are. There. Okay. Ensure you're still working in the primary region, especially if you're following the links above to open the service console at the right screen. Okay. So we got the thing, right? Primary region, we got the service like secret value. You've now collected all the needed parameters for the primary region. Next, you'll be collecting the needed parameters for the secondary region. So now let's go here. Let's close these. I'll also close these maybe, and this is in the primary region. I've already seen these. I don't want to look at this for now. Reload window, and yeah, let's click this. Let's look at the parameters. Here it will say agree tracking and all, deploy AMS3. I don't know what is AMS3, AMSv2, backtrack and all, global database cluster. Is it secondary? I think it should be yes over here somewhere. Is secondary? Yes. So everything else is no. So yep, the outputs you should see. So superset being deployed here. Superset, I think global database, that's all. Based on that, you'll deploy the superset. So secondary region, stack set, Aurora lab, superset URL, username and password. I think we have already taken that. We just took it. So US East one secondary thing, we just took it. So yeah, superset, right? Okay, cool. The username and password for the Apache superset application should be the same in both the primary, but the application URL endpoints are different. In the secondary region, open the thing and details of the database cluster. So okay, and so if not already selected, click on the connectivity and security tab, note down the data endpoint, verify that it is in available status. Okay, it is still not in available status, but it's okay, I'll get it. I think we have already gotten it here. Yeah, secondary. Yeah, cool. So I think that's all. The writer endpoint is also displayed, but it is marked as in creating an or inactive state. So this is normal. The cluster endpoint will only be activated when a secondary region is promoted to standalone DB cluster. Cool. At this point, you have collected all the information needed for both the primary and secondary regions, and you can continue configuring the application. So open a new browser tab or window. Apache Superset is a web-based application running on an EC2 instance in the primary region. Simply paste the Superset URL from the primary region into your address URL bar. So we're looking for the primary region one. So this is the one. Oops, I should copy this and put it here. So we're looking for the superset URL in the primary region. So I believe this is the one because this is US West 2 is the primary region. So let's put that here. So it is you should see the login page for Apache Superset. Type in the values of this. Site is not secure apparently. HTTPS can we do? Because we chose HTTP. Can we get HTTPS? HTTP, HTTPS. Yes. Interesting, it doesn't open up yet. Yeah, the non-secure part happens. Can we get this? Okay. You are in incognito mode. Okay. Oh, so HTTPS is not allowed. So let's just go for HTTP then. Continue to site. Okay. Cool. So here we'll say the username and password. Username is admin. Password is this. Admin. Password is this. Okay. Next, you will create a new data source for the Apache Superset in order to connect to the Aurora global database cluster. In the Apache Superset navigation menu, top bar mouse over the plus sign, click on data sign and connect database. Okay. So cool. We have COVID, vaccine dashboard, something and all. List users, database connections. Do we have any? We already have one. Oh, this is an SQLite which is running locally, I guess. So data connect database, I guess, or we can just say connect database. So oops, not this. Yeah, connect database. So give MySQL presto. Okay, so supported database. List is big. Apache Druid, Hive and all, Spark SQL. I think there is this. Interesting. We can say back and we can say MySQL and host is cluster endpoint 3306, my lab, username and password, Aurora lab, writer endpoint. Okay. So friendly display name is display name. Password retrieved before from the secret. Okay. So we just got the username and password, right? So this is the username and this is the password. Database name is my lab 3306. URL is basically US West 2, this one only. Because US East, this is reader endpoint. I want oh wow. I want Aurora reader endpoint. Just a moment. This is US West 2. The other one should be US East 1. Yeah, that's a default. Anyways, I want Testament. Read. So I have the reader endpoint over here, but replace cluster with the Aurora cluster endpoint retrieved previously in the primary region. So weirdly, I have reader endpoint over here. This is secondary region thing. Reader. I think this is okay. This is RO. Oh yeah, this is the one. Yeah, cluster endpoint. Okay, writer endpoint. I wanted to do this cluster endpoint. So this. So SSL. I don't think we need it. Connect. Any additional parameters? No. Cool. So connect. Cool. I think it's connected. So in the next screen, I'll expand the SQL Lab section and check the following boxes. Expose database in SQL Lab. Allow create table as allow DML. Allow this database to be explored. Okay. So allow create table as allow DML. Allow this database to be explored. Enable query optimization. No. So these 4 things. 2, 4. 2, 3. Allow this. 2, 4. Oh, this one closes the whole thing, and then yeah. Performance. Nothing, huh? So schema, cache timeout, security, secure extra, containing additional connection configuration. This is to provide connection information for systems like Hive, Western, and BigQuery, which do not conform to the username password syntax normally used by SQL Alchemy. Okay. Impersonator, login user, other settings, metadata parameters, engine parameters again. Cool. So database settings updated and last modified now. Yeah. What is AQE? I don't know. Asynchronous query execution. Okay. Data modification or manipulation language. CSV upload created by superset admin. So click finish. Okay. The secondary region setup will be very similar. Open a new browser tab or window. Apache Superset is a web-based application that is also running on an EC2 instance in the secondary region. Simply paste the Superset URL on the secondary region. The URL will have the following format. Yep. I think the thing is like this. So here it says compute, and then this US West 2. Here it is actually compute 1. Can I say this US East one also separately? Like maybe say like if I do this versus US East 1 dot compute 1. Yeah, it can't be reached. So for US East 1, I think the region is not mentioned. Cool. Admin and password is the same. So this. And you should see the login page, type in the values, and let's look at settings. If you click settings, database connections, data, connect database, or just connect database, MySQL 3306, MyLab. We need to get the thing password retrieved before from the secret. So we need to give the right password for this US East 1. I think secrets manager. So in US East 1, this Aurora VS Code. Okay, interesting. So I'm wondering what password did we give when we created the thing. I'm guessing it will have the same password, is it? Because US West 2, this one has the secret cluster admin user. And this one seems to have configuration security. Any security? Oh yeah, there is the security here. So enables you to this. Weird. Enables you to share a database. Okay. You can't share encrypted data with the default service key for RDS. Okay. I don't remember what I did when I created this. Okay. Let me just go to this or this. And let's say if I say add region, if I say global, add AWS region, secondary region, I say Ireland, let's say. Let it load. Ohio, US East, okay. Why does it take so much time? Okay, not bad. Ohio is taking a lot of time for some reason. Okay, yeah. So here in connectivity, additional configuration. Okay, there is no way to say which secret it is, huh? Secret. Password. Okay, so I'm guessing it's the same secret or the password is being used. Okay, cool. So then we just have to say the same username and password, which is basically this one only. So I guess everyone has the same username and password. It's a single entity. Password is this, username is this, and display name is secondary endpoint. You can just call it the secondary endpoint. And we need the reader endpoint over here. This will be this secondary cluster US East one. Yeah, these are all US West 2. Cool. So connect. The host name provided can't be resolved. Okay. Oh, this is still not created yet, is it? Yeah, this is still in creating state. This should be available soon, and then we should be able to do this. We need this to be available. So once that is done, in the next screen, we leave the default selections, click finish. Okay, so if you no longer have a browser window or tab open for Apache Superset in the primary region, go ahead and log back in and use the same sys as described into configure application in primary region. In the Apache Superset navigation menu, mouse over SQL. So then click SQL lab. Okay, I need to wait for this, by the way, so that this comes up. Secrets, I think I can close this. I think I can close this one also, right? So click SQL lab. In the web-based, so we when we are done with this, monitoring, use write forwarding, and switch over and failover. Okay, what's the difference between switch over and failover? Wow. The global secondary, simulate a primary region failure, connect and verify the switch over. Switch over global database back to the old primary. Simulate a primary, so you can just randomly just switch over without any failure. And if you simulate a failure, then failover to secondary region, and the simulated failure in the primary region, observe backups. Interesting. Cool. So in the web-based IDE with superset that displays on the left menu, select MySQL Aurora Lab writer endpoint for database, and then select MyLab for schema. Okay, so SQL Lab, and then MySQL Aurora Lab and writer endpoint, and then MyLab. So this is in the primary region, right? So I can actually go ahead and do this already. So SQL, I can just click this also. SQL lab. This is in US West 2, the primary region. Writer endpoint, schema, MyLab, and then select my first schema. Okay. Yeah, so there are many. I'll just choose my lab, select see table schema. So copy and paste the following SQL query in the editor and then click run. Okay, so drop table if it exists, drop procedure if it exists. So copy this. Okay. Um, okay. So we are doing this create table global database test one primary key integer like PK is primary key, so primary key PK. I mean they're going to use it as primary key, and that's why PK the name. Generate number and not null and all that. Auto increment for primary key procedure. Insert random in number of rows integer in min val integer max val integer. I integer I is equal to 1 start transaction number of rows do this is input I guess. This is also an input. So get generate number values min val into max val minus min val. Okay, and insert random. Cool. So we are running statement 5 out of 6. There are 5 statements, 2, 3, 4, 5, 6. Yeah, it's running this now. So there are so many rows it's adding. So basically 1 million rows. Yeah. So once this does the whole job of 1 million rows, once it is done, this may take about 30 seconds to complete. It is okay if you see the offline indicator before receiving the query results. Where is offline? Is it finished? Rows return, 1 row returned, count is 1 million and sum is this. Okay, MD5 SHA of the average and number is this. Okay, so it's okay if you see offline indicator before receiving the query. SQL creates a new table and randomly inserts 1 million records into the global database. Note the results down in a notepad or leave the browser window open. I'll note the results, copy to clipboard. And keep it here and also here. Maybe something like this. Yeah. Cool. So now, similarly in the Apache Superset navigation menu. So okay, now next, if you no longer have a browser window or tab open for the secondary region, go ahead and log back in using the same steps. Okay, similarly, SQL lab in the webbase ID within superset on the left menu, select Aurora lab secondary endpoint and copy and paste this. It should show 1 million. So basically, first of all, I need to see if this is even ready. This is not yet ready. I need to connect to it, then only I can run this. So yeah, this is still not ready. But the reader is available. Let me see if I can actually, port is closed. Yeah, see, it's connect. It's able to connect, interesting. So allow create table, no need. Yeah, DML data modification and all, we don't need this time. So in SQL lab, can I connect to it? This time I'm in the US East one. So here I can type in this thing, select count this. I think that's what they wanted us to do. Yeah. So copy and run this in the secondary region. So just copy this, run. No such table GDB on. So I think this has to, this is in SQL, right? Sorry, secondary endpoint. My lab, run. Yep. So we have it. It's already being replicated and all. This is available. This is getting created, but it's available, I think, already. And so note the results. The fields should match exactly the same as the previous results in the primary instance. This includes the count of records, some of randomly generated values, and the MD5 hash of the average of the generated values. This illustrates the way you can interact with the various regional components of the Aurora global database and how data is replicated from the primary database cluster to the secondary database cluster. Interesting. So this should be the same. Copy, and we actually see that this is the same and that these are the same too. Yeah, so you can actually see these are the same. So now let's move on to the next thing. So we have connected an application and all. So we've seen this, how data is replicated. So monitor global database. Amazon Aurora exposes a variety of Amazon CloudWatch metrics that you can use to monitor and determine the health and performance of your Aurora global database. In this lab, you will create a Amazon CloudWatch dashboard to monitor for latency, replicated I/O, and the cross-region replication data transfer for our Aurora global database. Okay, so we look at latency, replicated I/O, and cross-region replication data transfer. So we'll be looking at, we'll be trying to generate a load and monitor cluster load and replication log. So you'll use Percona's TPCC like benchmark script based on sysbench to generate load. So for simplicity, we have packaged the correct set of commands in an Amazon Systems Manager command document. Okay. I think we've run this before. I'm not sure. Let's see. So you'll use this run command to execute the test. If you have not already opened a terminal window, so once connected, so I think this is, ensure you're still in the primary region. So this is in the primary region. We're going to run the Aurora Labs sysbench test. So this should be in the primary region, and this is the VS Code thing. We should ensure that we are in the primary region. Let me just ensure that. Wait. So this one should be for this, because VS Code for this one looks different, I think. Yeah, this is different. D34 D10, yeah. Echo AWS region. Can I see the AWS region here? Yeah, it's US best. Awesome. Cool. So I want to run this. So let's run this. I think I've seen this before. The So I think the sysbench thing, we've seen it before. Okay, this is modifying, still modifying. I want to actually open up the, this is in US East one, okay. I want to look at Systems Manager and look at it in primary region. So there's I want the command documents, and I want it in the owned by me. Yeah, here it is in US East one. I want the US West 2 one. So sysbench test, I think content, it should connect to the cluster endpoint. Parameters, okay. So did we give the right parameters? I don't think so. Document name, instance ID, that's all. I didn't give the right parameters, right? As in, it needed parameters. I didn't give it any parameters. Cluster endpoint. Interesting. Here, sysbench, content. Oh, default is there. Okay. This has a default. This doesn't have a default. Interesting. So this one has the default, and this is the MySQL cluster, and then database schema, DB user and all. That is the same here. The DB user and the DB password is not, there's no default here. And then drop schema if exists, sysbench tpcc lua, they run the thing and it says run. So here it's, I think here it's prepared. So yeah, create the schema and then finally connect the MySQL and finally run this. Cool. Using MySQL, they create the schema. They give this to MySQL. Cool. So I think this should be running now. And the command will be sent to VS Code ID test of instances, which will prepare the test data set and run the load test. So this should actually give it to Amazon Systems Manager, and that will run it on the EC2 instance. So it may take up to a minute for CloudWatch to reflect the additional load in the metrics. You'll see a confirmation that the command has been initiated. Yep. And then in the RDS service console, select the Aurora MySQL cluster primary if not already selected and toggle to the monitoring. Okay, so we're going to be looking at this. You can close these, I think. These are the same and the same. So just close these. So I can actually have the same thing here. Okay, I'll just copy this once and say Aurora Labs is bench test. Aurora Labs is bench test secondary region. This is a JSON. There are no defaults here. And then finally I'll take this and say Aurora Lab sysbench test primary region.json, and we need to move this. Okay. I need to move that. Let me clear it. So where is it? Oh, this one. Yeah. Put it here. Yeah, close it. Cool. Yeah, now it is here. Secondary region. Okay. Let me close some of these. Cluster aware thing. Downloads. Alright. Cool. So now I'll actually go ahead and close these and go to the MySQL cluster. Check out the monitoring, and this should have some metrics that says, hey, something is wrong. Like, it's crazy. Something is going crazy. There should be replication lag and all that. So on the secondary, by the way, these are available awesome. So however, they were accessible from Superset. So yeah, aborted connects, active transactions. This is in the last 3 hours. So let me look at CPU utilization. Yeah, this has increased in the last few minutes. I can look at it as last 15 minutes. Yeah, this has increased. Maybe let me take it last 30 minutes. So yeah, you can see it increase. Idle time has gone down. It was idle a lot before, but now it's not idle much. Right, node 1, node 2, and the cluster itself. I wonder how the cluster value is, if it is the mean of the two. 89 plus 56 divided by 2. 89 plus 56 divided by 2. 72.5. Yeah, I think it's the mean. Cool. Load relative to number of vCPUs. Yep, the load is increasing. Cool. So select MySQL. If not already selected, toggle them. You'll see a combined view of both the writer and the reader DB instances in that cluster. You're not using the reader at this time. The load is directly only to the writer. Navigate through the metrics and specifically review the CPU utilization, commit throughput, data modification or manipulation language throughput, select throughput metrics, and notify they are fairly stable. Notice they are fairly stable beyond the initial spike because of caused by this bench tool populating an initial data set. So next you'll shift focus to the newly created secondary database cluster. You'll create a CloudWatch dashboard to monitor 3 key metrics relevant to global clusters and secondary DB clusters more specifically. So number of write IO replicated to the secondary region, the amount of redo logs transferred to the secondary region in bytes, so data transfer bytes, replicated write IO, and how far behind measured in milliseconds the secondary region drags behind the writer in the primary region. So how many seconds behind, how much time. So service console, you're going to work in the secondary region, so this is US East 1. As you have multiple browser tabs and command line sections open, please make sure you're always operating the intended region. The CloudWatch service team is in the process of updating the service console web interface to improve the experience. Depending on when you're running the labs, you may be offered the old or new experience. A banner will allow you to switch between them. The screenshots below are using the new console experience. Okay, cool. So we're looking at US East 1. Weirdly, this has the Aurora serverless V2 thing. So now we'll be looking at dashboards. We'll be creating a dashboard with 3 metrics. So Aurora Lab global database dashboard. Okay. And then next add first widget on the dashboard that will show replication latency between the secondary and primary cluster. Number. So metrics. Is it a metric thing? Number. Okay. In the metrics tab, select RDS. Okay. Metric. Number. Okay. In the metrics tab, this is the metrics tab. Select RDS. And then the database cluster identifier source region. This is the one. Source region. Yeah, this is the one. Cool. Done. You should now see. So basically, metrics. It's a metrics group. Basically, these are metrics groups. So we have to choose the metrics group, which is database cluster identifier and source region put together. So you should now see a filtered list of metrics. Choose a metric named Aurora Global Database Replication Lab. Okay, this is the one. Okay, choose it. And then there are other ones transfer by its aggregated IO, progress lab, database RPO lab. I don't know what that is. RPO lab. Recurring point objective. Okay, wow. Okay, so the widget preview should now be on the top with a simple metric of the lag time in milliseconds. Give the widget a friendly name by clicking the name added. Rename the widget to global database replication log lag average 1 minute. Apply, click submit. Okay. So this one apply. So timing, persistent time range. You can now persist the time range for this widget in your dashboard. This widget will then keep its time range and be independent from the global dashboard time range figure. Okay, interesting. Is this 1 minute though? North Virginia, so here, US East 1, here, and graphed matrix is this. Yes. Average. Okay, so it's the average. By default, it's the average. You can actually see is the, so confirm your settings are similar to the example below. So on the bottom, click on the graph matrix, because we have said it's one average in 1 minute. Average is the statistics. Button to further customize the view. Under the statistics column, you want to change this to average and period to 1 minute. By default, it is that only. It's average only. Average. I mean, that's the setting, not the situation. So period is 1 minute. So create the widget, and you should be good to go. Confirm your settings and create widget. Cool. So now you have created your first widget. You can set this to auto refresh on a set interval on the top right fresh menu. Auto refresh every 10 seconds or something. Anyways, yeah, there is a save. When you reload this, it should just come up. I wonder how it shows to other people. If I say auto refresh, is this, will it retain the auto refresh? Yeah, it does retain it. For me, for other people, maybe it is a user based thing, I don't know. If it is a user based thing, then only for them. If it's a global thing, yeah. It shouldn't be a global thing, I think. Anyways, so you can add widgets individually to the dashboard to build a more complete monitoring dashboard. However, to save more time, you will simply update the source of the dashboard with the below JSON specification. So view or edit source. In the text box, we will put this in. So JSON. So this is the dashboard that we have. So in the text box that appears on the screen, paste the following JSON code. Be sure to update the AWS region to match your secondary region if needed in the code below. Also, if you use different database cluster identifiers names for the database clusters than the ones indicated in this guide, you will have to update those as well. Okay, so these are right, and the region is US East 1, so I think it's all good. So metrics, database cluster identifier is this, and so we need replication lag, here it's the maximum. What is this, dot. I think it's the same thing. Here it doesn't say dot, okay. Dot, transfer bytes, replicated write IO, okay. Cool, so maximum versus average 1 minute. Okay. I think by default it's average 1 minute. Here you can actually see it being like, say this one is average 1 minute. Start is average. By default, I think this is the stat for all the metrics, but then if you say what is the stat, you will get maximum also. Maximum versus average in 1 minute interval period. So, and period y-axis and all that. This is stat sum aggregate, so sum. Okay. I think when you create a widget, you will know that when it's a number, for example, let's say RDS or whatever, say you choose this one and you choose this. In the statistics, in the thing aggregate, you can actually find out, say, maximum sample count. Many things can be the aggregate, so yeah. And so we're going to do actions, view or edit source, remove this. This one says period here itself. So source region US West 2. Oh wait, this is for, yeah, this is US East 1. Interesting that this actually took up US West 2. I should actually change it. Edit? How come? This is US East 1. This is wrong. I want it to be US West 2. Right? Or no, this is US East 1. Sorry. This has to be in the secondary region. I want to be in the secondary region. Oops. So US East 1, US East 1, everywhere US East 1. So this is right actually. So, but here alone it says US West 2. How come? I mean, that's what I think. That's what I meant to change. US East 1, okay. Browse. US East 1, okay. Okay. Source region, okay. I think we don't have a source region. We'll just use US West 2, US East 1. Yeah. So update. Oh, it doesn't show anything. Okay. So I think we have to say the US West 2 then. Interesting. Update. So there is a source region that they mention here. So US East 1, US East 1. Interesting. Let me see how this goes. So let me copy this and let me edit this, put this here, update it. It does show things properly. View and edit source. I think US West 2 is not even here. Yeah, I don't know why it needed that there. In this case it shows up pretty well clearly, and for example here you can actually see there's no source region that's needed, right? I don't know, somehow the source region came up. I'm not sure how, but that's fine. So yeah, so in RDS this, yeah, source region, for some reason it says this. I'm not sure why it says that. Here did it say anything? Source region? Yeah, US West. Interesting. Interesting how that works, because now we have not mentioned the source region. So I don't know. If I say US West 2 here, nothing shows up. US East 2, US East 1. Yeah. Cool. So this one, if you do this, metric name, namespace, all good. Seems fine to me. So add query, RDS. So add dynamic label. Anyways, add math functions and all. Anyways, so I think it's pretty straightforward. So you can see that the lag is 116 milliseconds. Available replication metrics 109K, 7.19 GB, and in the last 1 hour you can actually see the load has gone down. I think the thing is over. On the bottom, click on the graphed metrics and under the statistics. Okay, so yeah, we have put the JSON now. Update to change the dashboard. Click Save Dashboard to make sure the dashboard is saved with the new changes, and you should see it. The Aurora replicated database, Aurora Global database replicated IO and Aurora Global database data transfer bytes. Metrics are only supported once an hour, so you may not be able to see any data for those metrics depending on the timing of your lab. If you're doing other labs, please continue with those labs and come back later to check these metrics. Okay. So transfer bytes and replicated IO, I think we have some metrics now. Transfer bytes and replicated IO. Cool. So we're using writer forwarding and then failovers, switchovers and failovers. We'll do this, and we'll be doing SageMaker and these two next. Cool, I think we'll have enough time. So you can enable read or write capability for one or more secondary clusters in an Aurora global database. So in this configuration, Aurora forwards SQL statements that perform write operations to the primary cluster. This feature is called write forwarding. So we'll put this here. So this feature called write forwarding helps you find helps you to avoid implementing your own mechanism, okay, to send write operations from a secondary AWS region to the primary AWS region. In this lab, we'll exercise this feature and explore the different data consistency modes associated with this feature. Gather the needed information, create a database schema, insert data from a secondary cluster, test consistency modes with a simple application, choose the right read consistency mode. Okay. So gather needed things, cluster endpoint, reader endpoint, not active in the secondary region. So RDS search console, so okay. So cloud formations, click on start named Aurora lab, VS code fine, okay. So ensure you are in the primary region, okay. Change to the outputs tab and client ID, URL and all that. So I think we have these already. Reader endpoint, we have it, and still working in the primary region, especially if you are following the links. So I think this case we have to be in the secondary region. If these values are, you may not have selected the correct region or the lab environment was not initialized with the global database feature enabled. If you're participating in an organized event workshop, please reach out to a lab assistant for help. Cool. So the writer cluster endpoint is also displayed but is marked as this inactive because the cluster endpoint will only be activated when a secondary region is promoted to a standalone DB cluster. So at this point, you have collected all the information needed for both the things, and you can continue with the lab. Create a database schema. The following schema will be used in all the tasks in this lab. While you can issue data manipulation language requests such as insert into, update or delete using write forwarding, data definition languages and certain other operations can only be performed directly on the writer DB instance of the primary cluster. Therefore, the schema needs to be created on the primary DB cluster. If you've not already opened a terminal window, please open to do so now in the primary region. I'll actually connect to the secondary region. Let's look for secondary. I will open the VS Code. Is this the same password for me? No, it's a different password. I'm actually going to connect to the secondary cluster and let's see how that goes. I'm going to actually use DML commands there. So is the database and thing password mentioned? I want the color themes dark. Okay, dark plus, cool. I'll close this for now and open this, and let's make this bigger. So is this as big as this? No. Cool. So now does it have DB user? Nope. Cool, it's fine. Some key bindings okay, cool. So the username and password should be the same, so we can actually create the DB user and password. That's not a problem. I think I'll just do that. Export DB user, allow this, and administrator. Export DB pass, and cool. Here we are gonna be putting this. Let's see if this works. MySQL command not found. Okay, wow. I have to install MySQL now. So in the other one, you're not gonna be running MySQL, is it? So I can install MySQL apt. Okay, what is the package manager here? I forgot. Let me look at the document, systems manager document, it will have how to install this. In the Bootstrap, it should have had this in the documents. So change management, documents, owned by me. So this is in US East 1, Bootstrap client. In US West 2. Why didn't it create MySQL? I can't change this. Great. MySQL is not there here. MySQL, it is there here. That's weird. Has the Bootstrap completed here? I need to check that basically. Tail. Bootstrap complete. MySQL should be here. Oh yeah, now it's there. That's interesting. It got completed just now, I think. What's the time? 6:15. 6:22. So it got completed a long way. Why did it say? Oh, MyQSL. Sorry, it's not MyQSL. It's MySQL. Sorry. MySQL. Okay. MySQL. Oh yeah. So it's connected. I'm gonna run these now here. SQL this. Let's see if this runs. It says no database selected. Interesting. So I'm using this database. So one moment. So I created a database, drop schema, running in read-only mode, unknown database. Yeah. So we can't connect to this basically. Awesome. So we can connect to the main thing only here. So let's go here, and this is the primary region. I'll probably name it here itself, or create a file named region.txt and just say primary region, and this is US West 2. Yeah. Similarly, I'll create one here. I'll call it region.txt and call it secondary region US East 1. Cool. So here I'm gonna actually just go ahead and ensure we are connected to the primary thing. So basically in the previous one we actually got the cluster endpoint. This is the main cluster endpoint. The reader endpoint is for the secondary. So did we enable write forwarding though? Gather the read thing. Okay, we are yet to. Okay, so you're gonna get the cluster endpoint and the reader endpoint, I think. So let me see. So here we're gonna get this and this, I think. So this one, if I connect, let's see if I can connect to this and say the same thing. MySQL -h this -u db user -p db password with double quotes, or else it's going to be a problem again. Let's see if I don't give double quotes, how it works. It works. Good. Okay, so this is the read only. So I'm just going to say these commands again. Drop schema if it exists, read only mode. Oh, okay, awesome. So we have to remove this, and yeah, now it drops. So it says 0 rows affected, 1 warning. So these I can run now. Yep, it has created everything now. And now I'll quit it, and very simple banking applications. You can now track customer accounts and the transactions they make. So disconnect from the database using the following command. In order to demonstrate a more realistic load scenario, you'll now start Parameters, num threads, runtime. Okay. A background workload. So the global database is actively performing, not idle. You will use Percona's TPCC like benchmark script based on sysbench to generate load. Start the load balancer. Choose the tab below that matches best your circumstances and run the indicated commands. Okay. So interestingly, this will run the thing on. This will not run it on this, will it? Use my band and will the Aurora Lab suspense test. So this is in the primary region. So I'm just wondering, so this is in US East 1, okay. This is in US West 2, okay. And I want this bench. Here, does it use the my bank? My bank, no. The schema it uses is SBTPCC. So, and then the tables it uses is num tables. So yeah, I mean it doesn't use the schema. Like if we don't give it a schema of our own, anyways. It's weird. It's weird they created this bank thing, but they're not using it actually. So, anyways, and SBT is sysbench SB TPCC will only create its own databases unless I think you give some parameters to it. So TPCC Lua and tables, number of tables you just give and that's it. Not the tables itself, so just the number of tables and it will just use that schema or whatever. So anyways, we can actually just go ahead and run this. This will run it on, not here. This will run it on the default SB TPCC schema. So now we can actually go ahead and check out how write forwarding works. Next, you will create some customer accounts for the banking application, simulate the activities that a bank teller. Okay, so basically, in order to determine a more realistic load scenario, you will start a background workload. So not idle, you will use based on sysbench to generate load. Start the load generator, choose the tab below. Okay. So next, you will create some customer accounts for the banking application, simulating the activities that a bank teller in a branch location of a bank might do if that location is closer to your secondary AWS region. So, okay, might be if that location is closer there. So, if you have not already opened a terminal window, follow this, but make sure you use the it's a secondary region. And if you're accessing the VS Code, ensure it's set up correctly by following. Okay, once connected, so you need to set up the database credentials on the VS Code. If you've created the original transaction manually, performed a similar step at that time. But run the following commands, replacing the placeholders with values indicated in the below. So we have this already, but we can actually get this. So secret ARN and primary region we have to put it. So let's see if it can actually get it. So this is in US East 1, right? Secret ARN, secret, yeah, this is the one. ARN. So this is the secret ARN and the primary region is US West 2. US West 2. Cool. So now we can actually check this out and see if it is correctly doing things. we can actually see DB user and then DB password. Yep, it's perfect. Cool. So now we're just gonna go ahead and do this. And here we'll let these be here. Cool. So now reader endpoint, replacing the reader endpoint with the reader of endpoint of the secondary. Okay. Now let's do this. MySQL. Okay. Actually, can you connect to the primary cluster from here? Let me see. MySQL. Yeah, this one. Can you connect from here? Yeah, you can't, I think. Like, you can't even do a telnet, I think. You can't connect to that. 3306. Telnet is not there. Wow, okay. I will install it separately. Anyways, but you can't connect to it. That's fine. But you can connect to the secondary cluster. Yeah. So okay, so now we're gonna actually be running some stuff. Once connected to the reader DB instance in the secondary region, run the following command to activate write forwarding. To be able to use write forwarding, even if the secondary DB cluster is already enabled for write forwarding, you have to indicate a read consistency level. In this example, you are using the eventual read consistency level, which means your writes will be forwarded to the primary region, applied there, and you will receive a confirmation indicating the success or error of that operation. But the DB engine will not wait for those changes to be replicated back to the secondary region. As a result, any immediately following reads of the changed data in the same session or other sessions on the secondary DB cluster may return a stale result. The reads will be fast but eventually consistent. Okay. So if I just do this, I said create schema, running in read only mode. Now if I say create schema, it will say running in read only mode. Okay. Create table blah, no database selected. Show databases, use my lab, create table blah, running in read only mode. Okay. So set Aurora. Okay, so now we will do insert into. Okay, so what are the other things that you can set it to? So get so this value so initially it will say doesn't support write forwarding. So basically the value for this should be valid values eventual session global. I think we'll keep it as session first. I'll put it as session. If I put something blah cannot be set to blah. Okay. Session. So now if I do insert into, I think it will still not work. Once I put eventual, then it will work, I think. So for example, let's put it here. No database selected. Okay. let's select the database my bank. So when you connect, we'll say my bank, right? So I'll just paste this again. Running in read-only mode, running in read-only mode. Okay. So now if I actually say set this thing, it should work on. So SQL set this Aurora replica read consistency is equal to eventual, then it works. What if I give global? What's the difference? So global, what does it mean? Let me see if I can put this as global. Global, and let's see if this works. If I say global, if I put this, does it work? Okay, it works. For global it works. Eventual, I think immediately if you just do get select start from transactions, it should come immediately, I think. Interesting. Let me actually put this out here. Okay. So I need to check out what the global thing means here. Documentation for this, I need the MySQL documentation. Okay. So use local write forwarding. So global doesn't say what it means though. Anyway, so this one is clearly useful. This is related to Aurora, so what does global do? What does Aurora global do? So ensure that read queries on a secondary cluster will wait for replication to catch up with the primary cluster before returning results. So this is like a synchronous replication. Eventually is asynchronous, I guess. So strong consistency. So let's just put eventual now. I'll just put it as eventual. Yeah. So yep. Oh hey. Asynchronous replication with write forwarding, immediate write forwarding, synchronous replication, writes complete and show results only when the secondary catches up. Writes complete and show immediately. On secondary. Enables write forwarding, and here also application with immediate write forwarding. So write forwarding from secondary to primary, writes complete and show results immediately, and yep. Cool. So with that, note that the operation latencies are high because these statements are being forwarded to the primary region, thus incurring a cross-region network round trip. Okay, so next you can quit and you can just check the consistency, and we'll be doing switchover and failover next. So it's a simple application. So in this task, you'll explore the practical effects with the write forwarding read consistency modes have on a simplified bank teller application. This banking application, bank deposit, okay, allows you to display your account balances. So interesting. So I think this is part of this. So bank deposit, yeah. Cool. Eventual consistency. When read consistency is set to eventual, and then there is also session consistency. So results of write operations in the same session aren't visible until the write operation is performed on the primary region and replicated to the current region. Queries don't wait for the updated results to be available. Like the write queries don't wait for the updated read results to be available. Thus, a subsequent query might retrieve the older data or the updated data depending on the timing of the statements and the amount of replication lag. Start the banking application using eventual consistency and using the current database credentials. Replace the data endpoint with the reader endpoint of a secondary DB. So this one I have to just put to bash and this. I have 2 hours now. Complete SageMaker stuff and database activity streams and this. Okay. Cool. So let's change this to secondary. Yeah, this one. This is the read only. And cool. Let's use this. This is the secondary, right? Oops, not here. This. Cool. So it's asking some input. So notice the read operations to populate the account summary are fast. Next press D, then enter to make a deposit at the prompt. Provide an amount at the next prompt, integer values please, then press enter again. What do you see? The screen has been refreshed and the read operations to populate the account summary are fast again, but they show stale data. Okay. So account summary, okay. Deposit to add money, refresh the dashboard. D, make a deposit to your checking account. So 1,000. I'll just say 5,000. And it's not updated. So, but it shows stale data, right? So 0.028 seconds. You give 250. Okay, eventual deposit amount 250. Account summary a few times by pressing R and then enter the prompt. Eventually the account summary shows the new account balance. Okay. So you see R, you say R and then press enter. Should say 6,000, yeah. Cool. Now we can just quit, I think. Wait, let's see. So this is 6,000, yes. So now, yeah, we did get the account balance, new account balance finally. When read consistency is set to session, all queries in a secondary region that uses write forwarding see the results of all changes made in that session. Changes are visible regardless of whether the transaction is committed. If necessary, the query waits for the results of forwarded write operations to be replicated to the current region. A query doesn't wait for updated results from write operations. Oh, that's interesting. So all queries in a secondary region that uses write forwarding see the results of all changes made in that session. So if I make changes in the secondary, uh, the changes made in that session will be noticed, and changes are visible regardless of whether the transaction is committed. So if necessary, the query waits for the results of forwarded write operations to be replicated to the current region. A query doesn't wait for updated results from write operations performed in the other regions, or wait for updated results from write operations or in other sessions within the current region. So it's just within that session. So if you just do session now, same thing, let's quit, and here you say session. So now let's just say, notice that read operations to populate the account summary initially are fast. Press D and then what do you see? The screen has been refreshed. The read operations to populate are slower, but they show accurate data. Okay. So select read consistencies. Okay, so D. So 7,000. It took some time, but it's okay. 13,000, but it shows the accurate data. So try refreshing the account summary a few times by then pressing R. Should be fast again until you make a deposit again. So subsequent reads should be fast. Yeah. Oh, this is slow. This is fast. Interesting. So if I do deposit again and say 7,000, this will take some time. Oh, this took quite some time. The refresh should be fast. Yeah. Cool. So interesting. So the subsequent reads should be fast. Global consistency. When read consistency is set to global, a session in a secondary region sees changes made by that session. It also sees all counted changes from both the primary region and other secondary regions and other sessions also, I guess. Each query might wait for a period that varies depending on the amount of session lag. The query proceeds when the secondary cluster is up to date with all committed data from the primary cluster as of the time of that the query began. Okay, so we can actually put this in Python 3 global unexpected name or service. Oh, sorry. Yeah, it's supposed to be global. Yeah. So we can say deposit, and we can say 1,000. This took quite some time actually, but yeah, deposit 2,000. It should be 23,000, and yeah, it took quite a lot of time. And if you refresh, I think it should be. Oh, it is slow actually. The refresh is all slow because of global. Okay. Note that the read operations to populate the initially are slower compared to the previous consistency tests. And what do you see? The screen has been refreshed. The read operations to populate the account summary were also slower, but they show accurate data. Try refreshing the account summary a few times. Since each database query waits for the secondary cluster to catch up with committed data as of the time the query began. So reads should be consistently slower compared to our previous consistency tests. Makes sense? Cool. So above, you are able to experience what the impact of the consistency modes might look like to an end user interacting with the applications leveraging global database write forwarding. Which one is the right one for you? For your workload may depend on a number of factors. Below are a few example use cases. Use eventual read consistency when immediate subsequent read accuracy is not needed or can be overcome by other means. This ensures reads from the secondary region are always fast using an eventual consistent response. So one example is a order processing workflow. Given an e-commerce use case, when a customer submits an order, the application responds with an order confirmation screen. It is typically sufficient that the application receives confirmation that the writes were successful to the database without needing a strongly consistent subsequent read of the dataset. Another example is a user profile update workflow. Given a user profile service and a customer updates the profile, confirmation that the changes were saved is also typically sufficient. Let's say the end user updates their password. The password is not displayed back. Additionally, it will take the user a few seconds to navigate the interface to use the newly set password. This allows the database time to reach consistency of that change. Interesting. Use session read consistency mode when immediate subsequent read accuracy is needed and cannot be achieved by other means, such as caching the changed data application side. Financial applications, such as simple example in this lab, are generally good candidates for session level read consistency. Users may perform multiple transactions that build upon the results of the previous ones. In this case, the comparatively slower reads as a result of the changes are typically acceptable. Okay. As end users typically expect the system to perform some work as a result of their changed requests. Use global read consistency when globally strong read consistency is necessary. While using this mode may be tempting to simplify applications and avoid consistency-specific implementations, the higher query response lag as a result of having to wait for the data to reach global consistency may not be appropriate for most use cases. Trading applications or auction workflows where the functionality largely relies on every participant having an accurate view of the data state at any given point in time are good candidates for this consistency mode. Makes sense. So now we'll be trying out a global database switch over. So and then we'll do the SageMaker stuff maybe, and finally the database activity streams and IAM authentication stuff. So you can switch over Aurora global database to a secondary AWS region while maintaining the replication topology. Okay, and without having to recreate any secondary clusters. During the planned failover process, the cluster in the primary AWS region will be demoted to a secondary and becomes read-only. The storage volumes in all secondary AWS regions are synchronized with the old primary AWS region to ensure no data loss. When completely caught up, the chosen secondary, so basically it puts the primary into read-only, so no writes will work there. And then the secondary gets all the current data in the primary, and then makes the secondary promoted as primary cluster, and one of its existing read-only nodes becomes the writer node. This approach is intended for controlled environments such as operational maintenance and other planned operational procedures. So this lab contains the following tasks: failover global database, connect and verify to current primary region. So connect to the terminal window in the previous lab, primary region. So yeah. Multiple incurs you have to keep track of. Check the end of the deploy a global database lab on how to find the endpoints. Okay. So once connected to the database, use the commands below to create a table. Okay. So this is for SQL, and let's just say MySQL -h this. Let's just run it in the primary region. Are we running it in the primary region? Yep, we are running it in the primary region. Let's just kill some of these. I don't need these. So the bank teller thing was needed apparently. Let's save this. I don't know what changes I made. View or edit source. Did I make any changes though over here? Autosave off. Let me just reload and see. Anyways, how I'm not using this anymore, but oh yeah, I am actually using. Oh, this is basically the viewer edit source thing. One moment. US East 1. Yeah, this one. Okay. Update. Save it. I think it should be immediately saved or else we just forget. So we do need this because we are using it for the global database replication thing. And the superset, we can close it, I think. We're not going to be using it. Secondary, all available. This is the primary. Let's go ahead and get this done. So MySQL -h primary, and then do this, right? Okay, so select from failover test pf, take a note of the query results, you will use them later to compare. Okay, so in the primary region, action switchover or failover global database. So in the primary, this is the primary, stop temporarily, cross region, failover, remove from global now. I think we should choose global, yeah. And then click this, switchover or failover, okay. Global database. Do we need to do switchover, or so we are trying to do switchover here, I think. Failover is the next one. So on the dialog limited, switchover or failover, select switchover, select the value Aurora under the new primary. Okay. So switchover the roles of your primary and chosen secondary DB cluster. Use this operation on a healthy global cluster for planned events such as regional rotation regional rotation or failing back to the old primary after a failover. So so we did if you do a failover and then you have to fall back, you just do a switchover. This change might take several minutes to complete. No data loss should be occur, but you can't write to your global database during this time. Failover the primary DB cluster to the specified secondary DB cluster to respond to unplanned events such as regional disaster in the primary region. So this operation can result in data loss of any uncommitted work and committed transactions that were not replicated to the secondary. Oh, this is like immediately switch over, like switch it, failover. So switch over active cluster in one of your secondary to be the new primary. Select the Aurora under the new primary and then click confirm. Okay, clicked it. So it's confirming. So this is happening. Step 1 or 4. Okay. So now you'll be redirected to the databases page. Here you can monitor the progress of the global database switchover. In the top banner, you'll also observe the Aurora global cluster and the switching over state. And after the switchover is complete, you can see the banner at the top that shows confirmation of a successful operation. After switchover, the chosen secondary DB cluster is promoted to its new role as primary. One of the read-only nodes in the secondary cluster will promote to full writer status, thus allowing to assume the role of a primary cluster. Because all secondary clusters were synchronized with the primary at the beginning, of the process. The new primary, basically this will happen. So we are synchronized with the primary at the beginning of the process. The new primary continues operations of the Aurora global database without losing any data. You can confirm global database switchover has completed and your old primary has now assumed secondary role, cluster role. You can observe that writer instance of the old primary, now secondary, has become inactive. Under the connectivity, the reader endpoint will still be available. Okay, so let's see if this is done. This is in switchover thing, so it's being promoted. There are 4 steps apparently. I didn't see the full steps. It's not showing the steps also, but anyways, it's being promoted. So yeah, it's being modified. You can just do this. I think events should be mentioned here probably. In the global configuration recommendations, anyways, events. Yeah, ideally the events. Yeah, it should say ideally the events, it should say this is happening. So just a few minutes ago I just did global switchover, started old primary DB cluster, Aurora MySQL, and successfully shut down, successfully promoted. So there was no replication lag. It's promoted previous primary again. What? I thought this node 3 is supposed to be the writer. So promoting, I don't get previous primary again. This is already the primary. Why are you promoting again? And it's completed the initiated failover to database. So it's more like a switchover, but anyways, okay. Instance, Aurora has observed a change in DNS entries for the global endpoint. Okay. Global switchover to this completed. Looks like it's completed. And this is modifying itself still. So if you reload this, I think you should see modifying available, huh? Okay, it's available now. Awesome. So yeah, everything is available, and the events you should see it's completed. And finally you'll see this is the primary cluster, this is the secondary cluster now. Previously I think it looked different. And this is the writer instance, these two are reader instances now. So you can actually see that these are readers, reader, and this is also the reader instance. Role, does it say the role here? Only here, yeah. So now we should see inactive for this, right? So secondary thing, writer is inactive, reader is there, and then for this secondary connectivity, global writer, right? And then writer, reader. So for this the global is there, we have global writer, right? So previously I think it was the other way around. So now connect and verify the switchover, open the thing, cluster details in the secondary cluster, follow these instructions, new primary region, and then Cloud9 window in the new primary region. We switched over to our thing. So once connected, I think it's not Cloud9, it's VS Code, I believe. So yeah, this is now the primary. Oops. We can just quit this. New primary region. This one is new secondary region. So this is the primary now, and just a moment. Okay. So now we can actually, once connected, if you have not done so in a previous lab, you need to set up the database credentials in the VS Code. If you have created the original database manually, if you have from the secret URL, I think we've got this already. So new cluster endpoint, we'll say secondary. Yeah, this is the read only. We can give the other URL. F-h this. Cool. So now we can connect with this. Maybe MyLab. Was it? Yeah, MyLab. MyLab. And you can select start from this. And did we keep track of that thing? Yeah. So it should be the same. So 100 US East to input 20, 25, 7, 13, 650, 13. Yep. It's the same. Cool. And note the query results. This should return the new table and the record you entered into the database shortly before the simulated failure. Insert a new record to the table, copy and paste the following query. What do you expect the results to be? It should work. So, so US East 1 input. Oh, that was actually US East 2 or was it West 2? I think it's West 2. Anyways, this is 659. So here you should notice both your previous results before failover and the new record. Both your previous results before failover and the new record. Your application can now serve both read and write queries from what used to be your secondary region and serve your users as normal during a region-wide disruption. Cool. So switch over global database back to the old primary. From the earlier labs, you perform global database switch over of the from the primary region to the secondary region. This is how to switch back to the original. Switch over, and so here select switch over and click confirm switching over. And after the switch is complete, you can actually you can see the banner at the top that shows the confirmation of successful operation. After switchover, the chosen secondary is promoted to its new role as primary. One of the read-only roles in the secondary cluster will promote to full writer status, thus allowing to assume the role of a primary cluster. Because all secondary clusters were synchronized with the primary at the beginning of the process, the new primary continues operations of the operations for the Aurora global database without losing any data. You can confirm global database switchover has completed and your old primary cluster has now assumed the secondary cluster role. You can observe that writer instance of the old primary cluster, now secondary, has become inactive. Okay. So writer instance of the old primary cluster has become inactive under this, and the read endpoint will still be available. Oh hey. Cool, so let's actually do that once. I want to see the switchover happen. Switchover, this is the secondary, I'll make this as primary and then make this a secondary. Here it will become reader, one of these will become writer. So switchover, Aurora MySQL cluster, US West 2, confirm. Let's see the different steps it takes this time. Switchover of Aurora Lab MySQL secondary to Aurora Lab MySQL cluster. So this is the global, switching over the global cluster Aurora Lab MySQL global. Switch over of, this is the primary, current primary, though it says secondary. This is the current primary. Now this primary to this primary, so MySQL is beginning. So you can actually reload here and you'll see it's modifying this. Right, it's modifying all of it, and you can see switching over here, and you can see switching over here also. I think this will go away and go to the other one, and here you can actually see inactive and all that. If you reload here, okay, you can close this. It's modifying, switching over. This is available. Okay. This is still available, but this one is modifying now. Available as in the DNS endpoint is available anyways. So the next one is, step 2 is primary DB cluster Aurora MySQL is being demoted to a secondary cluster. So it's being demoted, okay. So name is misleading because that's how we named it. But anyways, we could have just named it 2 or something. Anyways, so this is being demoted, so this will become read-only, I think. So, and then finally the other one will catch up, I guess. So as you can see, so finally 4th step has gone. I don't know what was the 3rd step, I don't notice. Is being promoted to the primary cluster. So Aurora Lab MySQL cluster is being promoted to the primary cluster. So here you can see this has become the secondary. This is becoming the primary. One of these will become writer and this will become reader, right? So I think that's all there is. I think in between it would have tried to ensure that both are in sync after making one of them read only. So yeah. So here you can see this has become reader, this has become writer, right? So here you can actually see how they have three endpoints. One of them is a global writer endpoint, and the writer and reader endpoint, and this one, as always, the node endpoints, the DB endpoints, right? Even the ARN should say something like DB only, something. Configuration, the ARN says DB. Here it's cluster. Yeah. And what else? Here you can see the global writer URL, and you should see that here also, right? And it's all available and it's completed. Is now the primary cluster for this. Secondary clusters for your data now includes Aurora lab, MySQL links. Okay, cool. So now we're done with this. We'll do a failover now. This lab demonstrates how you can use global database failover to recover from an unplanned event in the unlikely scenario of an entire region's infrastructure or service becoming unavailable. Combined with an application layer that is deployed cross-region via immutable infrastructure or copying your AMIs across region. I mean, cross region, not across, or cross region or across one. Let's put this here. So you can further increase your application's availability. You have to ensure that your applications are also deployed cross-region while maintaining data consistency. Though this lab contains the following tasks: simulate a primary region failure, promote the secondary cluster, and the simulated failure in the primary region. Okay. So we're gonna connect to the cluster endpoint. MySQL -hex, this one, and now this is the new primary again. So this is the primary again, and this is the secondary. So you can't insert into here, I think. Oh, but it will do. It can do something. I don't know. Show databases. Show tables. Select start from lab. Insert into lab values 3, blah, 15 minutes. It's in read only mode. Cool. So we have to enable write forwarding, then only it will work. So you have to say set something. Only then it will work. Okay, so let's just. Okay. How do you get values? So this one we got this, yeah. So how do you get the value of this? I need to understand that though. Get environment controls review breakdown, how to set it, how to get the parameter, select at, okay, you have to just use select, of course. Just say select at and you should get it again. It should be unset again. So this. So select, yep, there's nothing. So write forwarding is not enabled here. Just a moment. Move camera. Yeah. So pausing is not working out sometimes. It's like, anyways, what? Okay, so we are in the primary region and let's connect. Drop the table, failover test one. Okay, region 1 input, so we'll put it and take a note of the results. So you can simulate an in-region failure using several mechanisms. See the test fault tolerance lab for hands-on exercises to test that out. So within the region itself, like you can simulate failures. So we did this actually. So for example, there are some commands I think for doing that. Like it's called failover DB cluster, simple failover. So we'll trigger a manual failover of the cluster. How do you trigger a manual failover? 1 moment. Test a manual DB cluster. So this. Even notification, yeah, testing nothing. Simple failover and so here basically we use the failover DB cluster, and the other way is injecting fault injection queries. You can just crash your system. So we have done this before, so all of that is done. So now, however, in this case, you will need to simulate that primary region becomes unavailable, including primary DB cluster. There is no comprehensive way to simulate such a failure, but you can simulate a long-term and large-scale failure by stopping all ingress or egress data traffic in and out of the Aurora global database's primary cluster. Okay. So then your lab environment contains a VPC network ACL. So network ACL, which is NACL, with a specific deny all rule that will block all ingress and egress traffic out of the associated subnets. This will essentially emulate a wider failure that will render your primary region DB unavailable to your applications. Open the thing, primary region, network ACLs. Okay, interesting. So VPC service console, and you should see a NACL named Aurora Deny All NACL, network ACL, access control list. So, and that is not currently associated with any subnets. Select it by checking the box next to the name and review both the inbound and outbound rules. In the bottom detail panel, you should see that they are set to deny all for all traffic. Okay, deny all, yes. If I click this or if I click this, rule number 100, okay. Type all traffic, protocol all, port range all, source range all. So inbound, deny. So all IP addresses, and then outbound, all IP addresses is denied. Cool. Subnet associations, nothing. So now I think details show up here, but if you click from here, you will see the details here. Yeah. Subnet associations and then tags. If you click this, tags will show up here, the details on the top. Anyways, cool. So toggle to the subnet associations tab of the selected NACL in the detail panel and then click edit subnet association button. The Aurora DB cluster is configured to use the private subnets configured for your lab environment and governed by RDS database subnet group created for your lab environment. So all these subnets are named with the prefix Aurora lab private PRV subnet sub followed by a number corresponding to the availability zone. You may need to drag the subnet ID column wider to see the names. Okay, let's edit this. So it's going in. We'll choose it all. So subnet 1, subnet 2, not public, we just need the private, I think. Public is not necessary. So select all subnets that begin with this name prefix. You can also simply use the search box to filter on the subnets with the private name and then select them. Okay, yeah, instead of doing this, we can just do PRV and just do this and select it all. Yep. And if you close this, it will show this. And it's PRV, public, oh yeah. Cancel, let's say cancel, I do the submit associations, this. Private, PRV, this is public. So save changes. And once associated, the NAC rule takes effect immediately and will render the resources within the private subnets unreachable. Your connection to the VS Code IDE should eventually also break with an error message indicating that the client lost connection to the server. Yeah, let's see. Let's just do select one. Interesting. Nothing works. Nothing happens. Am I supposed to connect from here? Interesting. Are they talking about this? That I won't be able to access? This is the public one, no? Private one, it should be able to access. It should not be able to access, but public one. Basically, this is for. Okay, let's go here, close this. Let's close this. I'm guessing we need to, let's say, access the global database failover to secondary region. I think this is happening. Oh shit, I put this in the US East 1. We should be in the primary region actually. They didn't open the primary, they opened the secondary. Right. So this is wrong. That's why I'm not able to access here. So this has to be removed. One moment. Interestingly, they have it here also. Details. This should be in US West 2, by the way. So subnet associations. Remove it all and save changes, and I should be able to access it now. Yeah. So this has to be done in US West 2. So here you have this subnet associations, private, not public, private, save changes, and now it should show this. Yeah. Now it can access it. Yep. Done. Cool. So now global database failover to secondary region. You're simulating a prolonged regional infrastructure or service level failure, at which point you would typically opt to perform a regional failover to your DR site for your application and database stacks. Next, you will fail over to the secondary DB cluster. Okay. Perform a regional failover to your disaster recovery site for your application and database stacks. Next, you will fail over to the secondary DB cluster in the secondary region. As a secondary DB cluster, for example, in the screenshots below, secondary region. Why does the status of my primary DB cluster and DB instance still report is available? You might also notice that in your RDS console, it will report the primary DB region and DB instance available. That is because you are merely simulating a failure by blocking all network access to your NACLs, and the blast radius of such a simulation is limited only to your AWS account, specifically to your VPC and its affected subnets. The RDS or Aurora service and its internal health checks are provided by the service control plane itself and will still report the DB cluster and DB instance as healthy because there is no real outage. So switch over or failover, and you need to choose failover and then to select Aurora MySQL secondary for new primary cluster, confirm, and you can monitor the process by observing the banner at the top and also by observing the changing status. Once failover completes, you should see the thing as new primary. So what's the difference between a switchover and a failover? During the global database failover lab, you saw that the secondary region cluster becomes primary and vice versa. You saw the pattern repeated in global database failover. I think this was switchover. So what is the difference between switchover and failover? So it's only possible when global database regions are up and running normally. During the switchover process, a selected secondary region is promoted to primary. Current primary becomes secondary, and replication resumes from the new primary to all the secondary DB clusters. There is no data loss. So basically, there's no data loss. It's all working. You just do a switchover. Failover is meant to be used during an unplanned event such as regional outage. In case of an unplanned outage, even if the primary region is non-operational, you can carry out the failover from a secondary region. However, since the global database replication is asynchronous, global database failover has a potential of data loss, which depends on transactions, data sizes, and other factors. So, end simulated failure in the region. Okay, so first we have simulated the failure, by the way, and now we can actually switch over. We can just say it is modifying for some reason. Weird. Okay, it's available only. Hello. So let's do a failover. Sorry, not a switchover. Failover. So switchover or failover. Confirm because it has data loss. So this confirm, and it should start now. So failover of Aurora lab MySQL cluster to Aurora lab MySQL secondary is beginning. Okay. So this was initially the primary. This is the secondary. Now it will change. Writer, reader. This is pending. This is now the global thing has gone off. This one might have the global thing. Oh yeah, now it has the global thing. Global writer. This is getting the primary now. It's pending though, failing over. So it's creating this. And writer, reader, it's coming out. It's available already. And this is a reader instance, it has to become a writer, and these two should become a reader. So, yeah. Cool. So, it is important to end the simulated failure at this point, as you will be unable to run through any subsequent labs if you do not. You've been simulating a large scale disruption by associating a network ACL NACL rule that denies all network traffic with the subnets where the Aurora global database primary DB cluster was deployed. Let's revert this to end the traffic block. Okay. And primary region, and once this is done, you can just unlock or uncheck all subnet selections and click changes. You may need to refresh the browser page or tab containing the VS Code ID in the parent at this point to restore connectivity. Observe backups. As part of the Aurora global database failover process, Aurora DB cluster will create a snapshot of the old primary region DB cluster. This snapshot can be used to recreate the primary DB cluster in a state it was before the failover was initiated. This backup is made available so customers can restore the old primary DB cluster and manually reconcile any changes that could have lost during failover if required. Okay. So typically this should be used as 2 snapshot system. So failover, yeah. You'll see a snapshot, unplanned data and timestamp. You can use the snapshot to restore and reconcile data from the old cluster if needed. Awesome. So looks like it's done. Failover was done. So it is resyncing, modifying. I don't think this will be able to resync because of the NACL thing. This is writer, reader, okay. Um, and I think we can't connect to it yet. So now the failover has been done. As failure is done, it has been done and it's successful. Failure is successful, it was successful. Is now the primary cluster. The secondary cluster failure now includes this. And let's reload this page just to see what it says or shows. It says this, it shows this resyncing. Same thing over here, I'll just close this up. So let me actually, this is the primary region, right? Here's was 2. Let me actually remove these subnet associations. Oh, interesting. I remember putting 2 or 3 of them. How come it's showing only 2? Yeah, 3 of them. Cool, so let me remove these, save changes. It should start showing resyncing and properly modifying the stuff. And properly showing the data at this point. The reader is available, the endpoint is available, but it says modifying. I think now it should work because it should be able to get the data from the secondary. Let's see how that works. So, and here I should be able to connect to the server. Cannot connect to the server to kill query giving up. I think this will take a moment. I'll close this up. Okay. So yeah, this one I need to see what you've done here because it says replication lag and it thinks this is the secondary, but currently this is the primary, for example. So I don't know. We need to probably tell exactly which is the secondary and then it should work. So here can't connect to the server to kill query giving up. I think we might have to end this and then start a new terminal, and now we should be able to connect to them. No, it's not working yet actually. Interesting. Because it is still not available, is it? Oh, I can't use this because this is not available, it's inactive. I have to be using the other one, the arrow, so that's the wrong thing. So I should say -h arrow. Okay, even that is not working. Interesting. And even this resyncing and modifying is not happening properly. I probably made some mistake somewhere. Anyways, now that we've done this, we can also observe the backups. I'll just go observe the backups once. Snapshot the feature. So this should have in US West 2 one snapshot in the primary region. But if the region itself is dead, would you have snapshots? And let me see. So observe backups. So if you go and look for snapshots, system snapshots, private snapshots, system snapshots, I don't know. Owned by me, private snapshots, public snapshots. Okay, that will be a lot. I think I clicked the wrong thing. There are a lot of public snapshots, I guess. So 17K, 18K, 19K, 20K, 21K, 22K, 23K, 24K, 25K, 26K. Wow. 30. I won't be surprised. It's okay. I'll just open up a new tab for now where public snapshots don't come up. Okay. 1998 plus, that's all? That's pretty less. Anyways, I want the owned by me private. So there are 51,216 of them. Anyways, so this for some reason it's not there. Snapshot is not there. Next, click on snapshots. Okay, in RDS console, not in EC2. Okay. So we have to look at snapshots here. In which region? This is the secondary region. Primary region, as in the first region that I was using. Yeah, so you can actually see how this is there. Interesting that this is actually a 5.7 MySQL thing, not 8.0. So this is for the green, no? This is the older one. Failover. Okay, system snapshots. One moment. This is manual. System snapshots. Here it should have failover. Yeah, this is the one. Cool. So this is the 8.01, and I wonder how this snapshot happens though, because if the whole region is down, how come it took a snapshot? I don't know. Anyways, so you'll see a snapshot and you can use this and reconcile to another. Okay. Cool. So machine learning, we were doing the SageMaker stuff. Let's see if we can quickly complete this off. And this one, yeah, you can see this. It's a snapshot, exports in S3, recent events, nothing. It was created a few minutes back and all that. For some reason, this hasn't resynced. I don't know why. Yeah, and I'm gonna close this up. Can I refresh this? Failed to fetch, okay. That's weird. Okay. Cool, so you can actually look at the SageMaker thing now, and I'll close this probably. And the IAM authentication and set up database streams. So SageMaker, it's a fully managed service that provides every developer and data scientist with the ability to build, train and deploy machine learning ML models quickly. This lab will walk you through the process of integrating Aurora with SageMaker endpoints to infer customer churn in a dataset using SQL commands. Okay, so we're looking at this. So create an IAM role to allow Aurora to interface with SageMaker, associate the IAM role with the Aurora DB cluster, add the IAM role to the DB cluster parameter group, and apply it. This is what I tried to do with Comprehend, but it didn't work out. I'm not sure why. So create a SageMaker integration function in Aurora, run the SageMaker inferences. Cool. So this, I'm going to actually run it. If you've not already opened a terminal, so this is in the primary region. So I'll just go down here, and so we say create role, and then I think that's it. We say create role, and then document is this, and then we change endpoint. We get the endpoint ARN. We have to put endpoint ARN. I'm sorry, I didn't put that properly. I think that is wrong. I think the SageMaker policy would have been wrong. Cat SageMaker. Yeah, churn endpoint, invoke endpoint. Oh, this is a query actually. Okay. So we have got the endpoint ARN actually. This is the endpoint ARN. Awesome. So it is the right thing. So we run it. So what we've done is basically we've created an IAM role, created a role, yeah, IAM role of course. Aurora Lab seismic access, and then effect is allow, principal is RDS. So the RDS service action is assume role. So this is for the trust policy, I think. And finally, you get the endpoint of the SageMaker, Aurora ML churn endpoint, and the ARN basically, and put it in the SageMaker policy JSON, and put that inline policy, and then policy document is this role policy. So in this, you have to put this role policy, and you're good to go. And the policy looks like this: invoke endpoint, and then yeah. Cool. So now let's actually look at the next thing to do. By the way, this has not resynced for some reason. I have no idea why. Anyways, I'll come back to this later. We don't have much time, so cool. So once this is done, associate the IAM role with the Aurora DB cluster. So we have the Aurora MySQL cluster, and if we do that, it says when calling add role DB cluster is not available for IAM role association. It's resyncing. Okay, that's the problem with that cluster. So we should probably use the new one over here, and damn it, we might have to reboot the DB for changes to array to minimize downtime using manual failure process. So the thing is, this is not available as of now. So I'm just wondering, and the other secondary one does not have 2 instances. I could use some other one maybe, or maybe this one. Yeah, and use that. Yeah, I guess. So you can use this and use this name for the cluster. So this is actually this one is actually the cluster. So let me put this here. Dash. And we are going to be putting here this cluster. Okay, let's see if this is working. Okay, that works. So describe clusters status. So we need UPG cluster here. Let's look at the status. It's available, great. Add the IAM roles, so parameter group cluster PG and SageMaker role parameter value. So this is for okay. Dash this. I need to check which parameter group this is. Is this the same parameter group for this also? I don't know. Aurora Labs CPG. I think it's cluster PG is parameter group, cluster param 3, and then this. I'm guessing it's the same for this parameter group. Yeah, it's 3BK by the way for this one. Copy link address, and basically just put this as this. Okay, So I'll just put this, and then modify cluster parameter group, apply method pending reboot, and then failover, reboot the DB cluster for the change to take effect. To minimize downtime, use the manual failover process to trigger the reboot. Okay, bash UPG cluster, UPG, okay, let's run this. Okay, it's done. Okay, so now, terminal. So describe cluster this status UPG. So it's failing over. Okay, so once it's available, create a SageMaker integration. Okay, you run the command below, placeholder with the cluster endpoint. Okay, I think I need the cluster endpoint here. So this is need the cluster endpoints. I'm just gonna go ahead and click this and say the writer one. Let me actually run this and see if this is available already. Yeah, this is available. So now MySQL -h, MySQL -h, and then -u this, right? Let's see if this works. ML test. Okay, so we need ML test. Do we have ML test here? Unknown database ML test. Yeah, so we need to actually create this database now. I think we have done the prerequisites here somewhere. Yeah, this one. We'll just create this. Drop schema if it exists. Load data should be available. So this. Missing credentials, cannot initiate S3 client. Ouch. Okay, so this is missing credentials. That one had credentials. Load data, did it work here? Create table, yeah. Load data into this. So you need the S3 credentials for this thing. Do I have the other database available with me which has these credentials? This is still in modifying state. Okay, let me just get the credentials this has them. Connectivity and security, manage IAM roles. So comprehend, integrate US West 2. So this one should have one more. Yeah, add role, pending. So it's modifying the cluster, so it should be available in some time. So modifying, watch. Once this is available, I think I should be able to, no, this is the MySQL cluster and this is not even available yet. This is the modifying thing and I want it. So this is reloading on its own. Status, pending. This is taking quite some time now. It's available now. So it's available. Awesome. Cool. So this, if I just use MySQL and go ahead and run this, maybe I'll actually say again this whole thing, drop schema and all, create a schema and test. I'll do it again. So yeah, missing credentials, cannot initiate a client. Right. So this is very useful. Thank you for writing it. Oh, these are just the comments I'm reading. So, okay. How do I get these credentials? S3 API return error. I want this. Um, S3 US East 1. Okay. Oh, this is in US East 1. Interesting. Hmm. Okay, I have only 45 minutes left. This is all still in sinking state. Can I connect to this one? Let's see if I can actually connect to this one, but this doesn't even have like a parameter group failover and whatnot to do it. But yeah, let me see if I can actually just create this here. If I can, no, this also is missing credentials. That's the kind. So Aurora labs my US East one and my data churn.txt. Where is this churn.txt? So this should be in a S3 bucket over here. So let me check out S3. General purpose buckets. So this one is called Aurora Labs MY. Directory buckets. Nothing. Okay. This is in US West 2. US East 1. Okay, SageMaker, US West 2. I think this doesn't matter which I choose, it's just all regions together. So, US East 1, North Virginia. Is this what I'm looking for? There are no objects here though. Buckets. There is something here, but S3 URLs is this right? What I don't get is how come AWS Aurora Labs my. So this says general purpose buckets. Table buckets. Directory buckets. Access grants. What access did it have? This one that I don't have yet over here. Comprehend access. Is it the comprehend access? Does it need that? It has SageMaker access. Does it need comprehend access also? Add role. We need to look at the roles maybe. Wow, the whole thing is gone suddenly and for a moment. Okay. roles. S3, nothing. Bucket, nothing. Okay, so RDS, monitoring rule, search proxy rule, order scaling. Hmm. This Aurora lab policy, we have given it to something. Are there any roles attached to this? Entities attached? AWS participant role are there. Anyways, I think workshop stuff. RDS policy, secrets manager, KMS. Okay. Manage job function. It is managed. All types. S3. Aurora. Customer manage is very few, by the way. This is a global thing. Just wondering how this thing has access. Okay, this has comprehend access also now, but don't think it will work. Load data, no database selected. Oh, let's just do this. Drop schema, create schema, alright. Oh, now it's working. Wow, comprehend access was required, is it? I don't know. Anyways, now that this works. That's weird actually. Now that this works, and this works in basically the upgrade cluster that I have. Now what I'm going to do is, we have 30 minutes, cool. Show tables, yeah. Oh yeah, this should have been because of the comprehend thing. Because how did this come up? How come comprehend? Where did we put it there? Use comprehend. We created this comprehend role only later. Interesting. Weird that it couldn't access it. Because anyways. So let's go here. Oops, this one. I had this. What show tables? Okay, show tables. No database selected. Okay. Use ML test. Show tables. Turn comments. By the way, here I want to actually check out in MySQL cluster the access this has. Integrate this, right? Role. Where is this role? I want to find out. Where is this role? So RDS US 2. So inline policy. This allows access to S3. Yeah, this is the one. For some reason, it didn't allow access to it. Trust relationships. RDS assume role. Last accessed just a minute ago, probably. Today. Tags, trust relationships. Anyways, I was trying to do this only. So I was trying to put this role. Anyways, it works now. So now, with that in place, I can actually run this thing. Go to ML test basically. Count ML test. Oops. ML test, and then create a SageMaker integration function. What is SageMaker endpoint? To simplify the Aurora Labs, the SageMaker model has been trained and deployed automatically for you. These resources were deployed when you selected yes for enable Aurora when you design the labs environment using CloudFormation. Provides model hosting services. So for model deployment, Amazon SageMaker provides an HTTPS endpoint where your machine learning model is available for to provide inferences. Once connected, the thing will SQL query to create channel using the alias AWS SageMaker endpoint parameter and passing the name of the SageMaker endpoint. Okay. So basically SQL. So endpoint name is this. Okay. So create function, and this is the function call returns this alias SageMaker endpoint name this. Okay. I need to understand what that does, but run SageMaker inferences from Aurora. So will churn. Now that we have an integration function linking back to the SageMaker endpoint, the DB cluster can pass values to SageMaker and retrieve inferences. In this example, we will submit values from the churn table as function inputs to determine if a particular customer will churn. This is represented by the true result in the will churn column as shown in the screenshot. Okay, so run this. Will churn true. So select star from will churn. Show tables. So select star from churn. Oh, there are a lot of 3,333 rows. In this, we were looking at will churn IN 65415. Okay. State 65415. Okay. So basically, we are looking at select will churn true. So instead, you can actually do this for copy this and show create table for churn. I'll just do /g. So state, account length and whatnot. So we can actually put this over here and state, account length, area code, int plan, email message, days minimums, day calls, night wins, night calls, and then int wins, int calls, customer service calls. Churn. Okay. So we can actually find out the user which has status this and all that. Just a minute. So I can look at these maybe. So I can say these, and then I can say cut this, okay, or actually yeah, cut this, do this, and then here do this. Equals this. Oops. So basically there are how many? 14. There are 15 lines here. So 6 I'll leave it. So this one I can actually take this and say this, right? And this one, churn equal to 4. So this we can just say at the end, and so we can just say select star from churn where empty set on. Interesting. Oh, I think it was created in, I don't know. I guess it's more like that was used to do the thing. Maybe let me do select star from churn limit 1/g. So maybe where state is equal to in. Oh, I think I put in correctly only. In. Oh. Oh. How come it worked here but not there? Oh, the where should come later. /g where state equal to in, and then 65 area code is okay. Account length is 65, area code is 415, plan no, email plan no. Wow, this is the one. Day means 129, day calls 137, minutes 228, 83, night miss 111, night miss 208. Okay, night calls 111. Int minutes 12.7 and int calls 6 and customer service calls 4. Oh, okay, customer service calls, not this churn, it's actually customer service calls, sorry. Okay, I think I missed that, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yep. Okay, so I think with this should work. Where state is equal to this. Yep. Okay, so it says churn true. This is not hard to inference, right? Because to continue the example, we will compare the training data with the SageMaker model's inputs. Outputs. So the churn table already contains actual churn outcomes for particular customers. We'll compare these results with the inferred results using the function to understand the model's effectiveness by executing the following query. Okay. So this says count star predicted to churn like true, then did churn, did not churn, round accuracy, from churn, from will churn, okay, where will churn, and then we give these like true. Interesting. I'm not sure how this works. Looks like they use the test data and also its own data. So some case when churn like true as did churn, case when round, so 100 into, okay, let's run this and see how that goes. So this So it says predicted to churn 402. Did it churn? 395 did not churn 7. Accuracy is 98%. So basically we thought these many will churn, but the actual is 395. So accuracy is not that bad. Disconnect and so clean up Aurora machine learning. So by using the Aurora machine learning, we've created additional algorithms. We recommend you to run the commands below to remove these. And so completed the labs, of course. So let's remove these. And these are a lot of commands. Just gonna close this and run these one by one. Oops, there was some sleep in it. Is it? Let's see how that goes. Oh, we can't do this for this. I think this is supposed to be for the upgrade cluster. So UPG and modify, and then again UPG. Okay. I think I'll just do all of this in one like this. And close this. Okay, I think I need to do something here. Okay, wait. Let me just copy this. I think you can just run this one by one. This, it's gone. This, it's gone. List models. So basically model name was not there because there was no such thing. List the SageMaker models and it wasn't there basically. And remove role, I think this has been done. Plus status is modifying. Okay, this is still in modifying state. Okay, cool. So these we can remove now, or however in some time it will go off by itself. So with that we have done the machine learning part. We still have so we've done the global database stuff and machine learning part, and we still have database activity streams pending and IAM authentication to access the DB class. Cool. So now let's actually go ahead and check out database activity streams. Interestingly, our this cluster is still in resyncing state, so I'm just going to leave it for now and focus on the UPG cluster that I can use. So this lab will show you how to set up and leverage Aurora database activity streams. Database activity streams provide a near real-time data stream of the database activity in your relational database. So I think it's kind of like related to change, data capture and whatnot. So whatever activity is going on, insert, delete and all that, I guess. When you integrate database activity streams with third-party monitoring tools, you can monitor and audit database activity. Using database activity streams, you can monitor and audit database activity to provide safeguards for your database and help you meet compliance, regulatory requirements. Solutions built on top of database activity streams can protect your database from internal and external threats. The collection, transmission, storage, and processing of database activity is managed outside of your database, providing access control independent of your database users and administrators. Your database activity is asynchronously published to an encrypted Amazon Kinesis data stream, so provisioned on behalf of your Aurora database cluster. So I think you'll be paying for this basically. So database activity streams have the following limits and requirements. Currently, database activity streams is supported only with Aurora MySQL version 2.08 or newer, which is compatible with MySQL version 5.7. Database activity stream requires the use of AWS Key Management Service KMS, because the activity streams are always encrypted with a customer managed key. So we will not be using a AWS managed key again. So yeah, create a AWS KMS customer managed key CMK, configure database activity streams, generate database load, read an activity from the stream, disable database activity streams. Okay, let's go ahead. And database activity streams requires a master key to encrypt the data key, so which in turn encrypts the database activity logged. See envelope encryption. Okay, we will read this later. So the default Amazon RDS master key can't be used as a master key for database activity streams. So therefore you need to create a new AWS KMS customer managed key in order to configure this. Okay, so let's go ahead and create a key on the next screen. Under this, choose symmetric for key type and encrypt and decrypt. So set alias, provide a description. Okay, Amazon Aurora Lab CMK for Aurora is this. Okay, create the key, symmetric, encrypt and decrypt, KMS, single region, alias is this, and Amazon Aurora Lab CMK for Aurora MySQL database activity streams. Okay, no tags, I guess. Finally, the following steps depend on the circumstances you are running this lab on. So in key administrator section, you can search for names to find them quicker. Aurora Lab ID region. Select and check the box next to workshop ops or workshop studio WS or just workshop, I know, ops role and participant role. Use the numbered navigation at the top to select all roles. Click next. In the key users section, you can search for the names to find them quicker. Okay, key administrators and users, same thing. Using your account, choose IAM role you logged in with or any other you want to administer the key, and select and check the box next to Aurora workstation region. There may be more than one. So let's actually create this key, and key administrators, we'll say workshop. Let us search for them. Workshop, I think there are a lot, is it? So we'll say workshop, ops role and workshop, participant role, ops role. How come this has WS? Where is WS in this? Only this has WS. Why do the others show up here? I don't know. So participant role, and then ID. So Aurora Lab ID US West 2, I think. Region, there may be more than one, so of course we want both. Okay. And Reaper role, system role, and all that. Reaper is, I think, probably the killer of this whole workshop studio. And again the same thing, key users. So I think we have selected a few. We have selected 4. Key users will be the same. ID, this, workshop ops role, and then workshop participant role. Cool. So we have this, and we have action, permission to encrypt, decrypt, recrypt, generate data key. In recrypt, it's star. Okay. Describe key, create grant, list grant, revoke grant for these, and then again some more things. So enable IAM user permissions, KMS, create, describe, enable, list, put, update, revoke, disable, get, delete, tag resource, untag resource, schedule key deletion, cancel key deletion, rotate key on demand, and that's it. Okay, so these should be created, and once we do that, we have the KMS key. If you've arrived at the MySQL cluster, start database activity stream. Okay, so I'll probably do the database activity stream on the UPG cluster because this cluster is dead almost. So I'll go ahead with this UPG cluster again, and I'll say here I can't say anything, I guess. You can only delete this. Here I can say start database activity stream, and then you can choose a key. Aurora Lab MySQL DAS, chose it, and asynchronous apply immediately, and then status column for the will show start showing configuring adding. Okay, so yeah, it's done. I mean, this is the key that we want, and asynchronous immediately pending, it applies all pending and current and pending modifications as soon as possible. The changes occur asynchronously regardless of the maintenance window. Okay, is starting for this. Okay, so let's just click this. So here status column will show this configuring. Okay, so there should be a status column. There's no status column, is it? Oh yeah, here it's showing. It should be showing configuring activity stream. Okay, so please wait until the cluster becomes available again. You may need to refresh the browser page to get the latest status. Okay, so let's just reload. Okay, so let's verify that this is enabled by clicking the cluster named and toggle to the configuration. Okay, configuration activity stream. Yep, status it's starting. So yep. So now next note the resource ID. Okay, which is which, and the kinesis. Okay, okay, the resource ID is this cluster, this kinesis string. You'll need them later in this lab. Okay, so generate database load. So we'll generate some load in this. So let's create some load. Bash Python 3. The cluster endpoint is basically UPG wala. So it's this one. So the cluster endpoint is this, and let's see if this is ready first. You have to wait for it to be ready, and then yeah, we'll run the load then. So you can quit the load generator script at any time. Okay, so you'll use a read-only workload to generate load so the reload generator script. Okay, so it's just going to read. It's going to pass read commands, select commands, or something like that. Not delete, insert, and all update and all. So read load generator script produces a variety of read queries using concurrent threads. If you have not already opened the terminal, please next run the command below. Appropriate value from the cloud formation stack outputs. You can quit. Okay. So is this available? Nope, not yet. So we need to get this resource cluster ID, and we need to get this data, this kinesis stream also. Let's see. So you will use an activity stream consumer script. So I think the previous one also you probably will have this. So this is a DAS reader, DAS activity stream, database activity stream consumer script .py. This one. Yeah, this is that, and then this one is reader load test. Reader load test for MySQL.py, and yep. So to read the events from the activity stream and print them on the command line. So you'll need to open an additional command line session to your session manager workstation to see the activity events produced by the load generator you are running in the other session. Connect to the session manager. Okay. For steps on what is the session manager? I think it's just the VS Code thing. Yeah. For steps on how to create a session manager command line session. Okay, so if you don't already have one active, so execute the command below. So this we're going to execute right in another thing. So resource stream name, we know We're gonna get it, and resource ID. So this is the resource ID, right, in the cluster, and the stream name is basically this. So I think it is going to be something like, let me see, it's not showing much. JSON formatter. Better look at the event. You can use the tools. I just have to format the JSON. Okay, sure. So for the Kinesis stream, I think the name is this. So I'll take the name. Yeah. So I think this is similar to this. Yeah. So weirdly, this is taking quite some time. Okay. I don't know if there's any error in between. Anyways, we still have like 10 minutes. So I'm just gonna quickly go ahead and check this out. So you can actually just read. So execute the command below in the session, in this new session, replacing the resource ID and stream name placeholders with the appropriate resource ID and stream name values you retrieved above. So you can actually see your output should look similar to the following example: log time, record, client application null, process ID, PID, username, database name, command text. So select, right, and then node 1, which host and all. So disable, open the thing, and if not already, the cluster is not always used, and click on this. Stop activity stream, apply immediately, and you should be good to go. Cool. So the status column on the RDS database homepage for the cluster will start showing configuring. The operation will be complete when the DB cluster and DB instances show a status of available. Okay. So this one is still not available, so I really can't do much here, I think. Maybe I can still try to run this and see if it works. So let me do this. Let me run the load test here. Table doesn't exist. Okay. Interesting. So I think this is based on. Anyways, can I use this? Can't connect. Connection refused. Wow. No module crypto, named crypto. Module not found. Okay, wait. Do we have some requirements txt here? So for the DAS reader, do we need something? DAS reader. So we need crypto cipher. Okay. Looks like we don't have crypto installed. Crypto install crypto. Okay. Cipher. Okay, I think that's fine. Probably that's it. I can just run this, I think. No module named crypto. Okay. Line 20. So I think pip 3 install crypto. How come it says no module crypto? I have 7 minutes. Python no module crypto. So pip uninstall, pip crypto easy install. So okay, I think I need to pip 3 uninstall crypto. That's fine. I think Pi crypto, I think it's called py crypto. Okay. Uninstall. Okay. Is this available yet? This is taking some time. Building wheel, failed during wheel. Oh yeah, I think there are some issues here. Okay, I still have 5 minutes, 6 minutes. I'm just gonna go ahead and move on to the next thing, which is finally the IAM authentication to access the database cluster. So I think this we have done. This is what is pending. So IAM authentication to access the database cluster. So there are a lot of these new things here. So create a new database user and grant permissions. Create IAM policy that maps to the database user account. AWS Lambda function to test IAM authentication. Test database access without attached IAM policy. And then test database access again with IAM policy attached. Check the error log for unauthorized access. Set up an alarm to get notified on failed logins. Oh yeah. To connect to and use a database, just a moment. I think I just can't do this, but I'm just going to stop this and leave it for now and keep this here separately just in case I want to look back and understand what just happened here. So just close this. I'll close this, by the way, and this also I can just close, I think. Yeah, and this I can just keep it separately. I'll come back to these probably, I guess. Yeah, cool. So we're looking at this tip. So to connect to and use a database, you need a user account within the database, right? So this database user usually is required to use a password to restrict access. So some authentication and authorization, say password or certificate or key or whatever, right? So within the database a user is granted permissions to perform tasks. In general, it is not recommended to store database credentials within an application. Recommended to update or rotate credentials periodically. This lab will walk you through one option to address the typical challenges involved in working with the database credentials. You'll explore the use of IAM authentication to completely avoid the usage of database passwords or the need of rotating credentials. Instead, behind the scenes, short-lived credentials will be leveraged. You will use an AWS Lambda function as an example to demonstrate how it works. But you can extend this example easily to EC2 instances or any other services that can assume a role. Of course, you can also use IAM authentication for IAM users or users of groups, user groups. Database user is created, IAM policy, Lambda function for testing, without IAM and with IAM, and then check the error log and set up notifications. Cool, so you will connect to the Aurora database just like you would do with any other MySQL based database, and okay. So we will use this and we'll use SSL. So secure connection. So weirdly the secure connection, basically let's look at the UPG one. We'll be using this and you will be using the US West 2 thing, not this. I don't think this will work. US West 2 I think will work, 2 dot something like that. Basically US West 2 hyphen bundle dot pm hyphen bundle dot pm. So I think that's what it is. Yeah. So yeah, and once you go in, you can actually create a user with AWS authentication plugin RDS. How does it work? Contains the AWS authentication plugin. Okay, this plugin takes an authentication token that is passed as the password. Okay, an authentication token is unique string of characters that Amazon Aurora generates on request. Okay, authentication tokens are generated using signature store. Each token has a lifetime of 15 minutes. You don't need to store user credentials in the database because authentication is managed externally using IAM. The required IAM policy will be introduced in the following steps. The token is only used for authentication and doesn't affect the session after it's established. Okay, let's create this thing. So alter user, this user can use only SSL, grant access, and finally let's keep these open so that I can actually try it out before it gets over, right? Yep. Let's open this up. Okay, cool. So create the database user account. So basically I've done this. To enable authentication for a certain user, role or group, an IAM policy is required. Follow the steps to create an IAM policy. So that grants the RDS DB connect action in connection with the database. Policy is create policy. Okay. Policies. Policy. Okay, it's 0, but it's fine. I'm just going to ensure that I can actually check this out for a moment. So event ended. I don't think it will refresh the page though. Oh, it did refresh the page. Damn it. Create function. Okay. Anyways, it was. Damn it. It was done. I think. Anyways, I think the environment will be gone now. And these will also be gone in some time. Interesting. Now this is available. Wow. Do we have restarting the terminal because connection lost? Reload. Yeah. This connection is gone, and yeah. Interestingly, Kinesis streams would be now present properly, and it would be working. I think. Error loading streams, data streams. Yeah, that's all. They killed the whole thing, but basically it has the status stopped for some reason. Anyways, I think now the token will not be valid anymore. If you just go to this DB instances, yeah, that's all. Cool. So that's all I had for this video, showing you about global databases, and then what else did we do? Database activity streams and stuff, and then there was something about how you can use IAM roles and not use database passwords at all. So something to read, and then of course SageMaker, and yeah, in global database I think we checked out failover and switchover and all. So yeah, that's all I had for this video. I'll see you in the next one. Bye bye.